started. Guys, you can see my screen, right? Just someone.
Yes, sir.
Okay. Thank you. Uh, okay. So we'll start. We'll first discuss the week's questions, and then we will go for some new theory. Okay. So just let me just open up week one's and week two's question. If anybody has any doubts on them, please unmute and ask one by one. Okay. Let me just open up the drive folder that I gave you. Yeah. You have access to these files, right? These are last week's, sorry, last round's assignment questions. Okay. So you can also do them. Anyway, you have access to the current runs assignments up to which week it is done, right? So yeah. So anybody has any questions on these two assignments? Have you get a chance to look into it, or I should go through them once? Just let me know. Can you speak again? I cannot. Can you speak again so I can hear you? Guys, if you have any doubts on week one or week two's previous runs questions, you can ask me now. Okay? Or I will assume that you have gone
Can
through
you hear
them.
me?
Yeah, I can hear you now. Yeah.
Sir, can you discuss the first question, last option, sir?
First question, last question, first week one, last question. What?
First week's first question, last option, sir.
Okay. So which of the following are supervised learning problems, right? So supervised mean we discussed earlier that it has to be this pair XY pair, right? So clustering Spotify user based on their listening. It's clustering means it is a unsupervised task, right? So first option is like initially striked out. Okay, weather forecast using data collected by a satellite. इसमें वेदर फोरकास्ट में क्या होता है ना यू आर ट्राइंग टू प्रिडिक्ट whether there will be rain tomorrow, right? Now we'll keep that in our bucket. We'll move to the next option. So predicting tuberculosis using patient's chest x-ray, right? So predicting tuberculosis using patient's chest x-ray. This has to be something like we have to know first, right? Initially some x-rays that whether they have tuberculosis or not. So this is also a possibility that will be correct. Okay, trading a humanoid to work using a reward system. It's a reinforcement problem, right? When there is a reward system, that is a reinforcement. So first option and the D, both of them are not supervised. So now the competition is this: weather forecast using data collected by satellite, or predicting tuberculosis using patients' chest X-rays, right? So
Sir, sir, you
yeah,
had mentioned that the D option is reinforcement learning, right, sir?
yeah, yeah.
Then how?
So it's like see whenever there is this reward system, right? See so what you are using, so training a humanoid robot, that is fine, but what you are using for training, you are using a reward system, right? You are only telling him what is wrong and what is right, not how to do it. Okay, so reinforcement means the system only provides the agent with uh, what is wrong, what is right, that information. Okay, by plus rewards or minus rewards. So plus reward means it will incentivize that action again, and minus means it will penalize that action. It will some action, like whatever he was doing at a particular state, if it gets penalized, it will not do that in the state. For example, walking, right? If somebody is walking on a slippery floor and he gets fell down from on that floor, right? So he get a negative reward from the environment. He fell down, right? Uh, and you can associate negative reward with pain. So just like that. So because it's not exactly telling how to do that, do task, how to walk, it is not a supervised task. It's a reinforcement task. So the options correct would be these two. If for weather forecasting also, you need to have a kind of earlier data. Like forecasting, predicting, these are like standard reinforcement learning tasks. So when there will be this forecasting or predicting, you can you can safely assume that the task is supervised. Okay. But anyway, you have to further look into the option. There's like forecasting, whenever you get this two terms, right? Forecasting or predicting, it most of the time it will be a supervised task. Okay. Clustering, whenever you get this keyword clustering in an option, right? It most of the time it will be an unsupervised task. Okay, and whenever you get a reward system or reward in the options, it's most likely it's a reinforcement learning task. Okay. Any other question?
Yes, sir, got it.
Any other question?
Sir, fifth one, I didn't able to do that one properly. The fifth
Okay.
question.
Okay, fifth question. So which of the following two function will yield higher training error, right? And is it drawn somewhere? Function F1, function
No,
F2.
maybe it is week one. It is not week one. Maybe week two.
It is week 2. Okay, week 2, question 5. Okay, select the true statement. Okay, now let's go with the first one. Subset selection method are more likely to improve test error by focusing on the most important features and by reducing variance to the fit. Okay, now next. Currently, we don't have any. So subset selection is what? You have a set of features, right? Let's say whenever you are training a supervised model, right? You have a set of features F. Okay. Now subset selection, what it does, it selects the most important uh, like features that contributes to training. And what it does, it selects the features such a way that the training accuracy improves, the testing accuracy also improves. Okay. Now let's go with this knowledge of sets like subset selection. Let's go through the options. So B, subset selection is methods are more likely to improve training error by focusing on the most important features by reducing variance in the fit. So it reduces testing as well as training error. Okay. So this would be not option. Both training and testing are by focusing on most important features by reducing. So it should be C. Why it is A, I don't know. So subject selection method do not apply in performance gain anyway. Okay, so this option sometimes what happens if you are so I'm confused with these two options. Okay, so why this A is correct? I can reason it like this. So for example, if I am improving testing error, right? So there is always this trade-off that if I am improving training error, that means I am overfitting. And if I am improving testing error, that means I am trying to make the variance less, right? So that it should not vary too much with it itself. Okay. So with that knowledge, if I am improving the testing error, that decrease the training error actually. Okay. So because you will be not touching all the points, that's why you are like predicting correctly in testing time. Okay. So the training and testing, we can improve them both up to some level. After that, you have to, if I want to improve the testing, I have to lose some training error, right? Sorry, lose some training accuracy. So that's why this should be correct.
Yeah. Thank you, sir. But what we have given assignment, it is different what you are explaining. Because if you more, what is it, week one, we have different question paper, set of different question paper.
Sir,
No,
I
these are
think they are asking for the current
uh,
week assignments, sir.
okay. Current week assignment. Sorry, these are not current week assignments. These are previous runs week 2 assignments. Okay. So let me open up this week assignments as well. Wait. This run.
So the week number one, we have I got an issue in finding a y hat.
Mhm.
They have given some of the data set.
But let me go to that course once.
Yeah.
Mm.
Sir, actually, even I had asked the question for that one, sir. Current weeks.
Mm-hmm. But that is not giving me permission. Okay, sorry. Sign out. I logged in a wrong email ID. So you have doubt in this runs week 1, week 2 assignments, right?
Yeah.
Let me just open that up. Okay, week 1 quiz. Okay,
Yeah.
so
Fifth question is there.
week 1, fifth question. This one,
Yes.
right?
Yeah.
Okay, so considering the following data set, fit a linear regression model of the form y equal to b dot plus v beta 1, sorry, b naught plus beta 1 x1 plus beta 2 x2 using the mean square error using the model to predict value of y at x1 x2 equal to this, right? And this is the entire data set x and y and this. So what is the doubt? So how to do this, right?
Yeah. How to solve this problem? I didn't able to get
Okay.
it.
Okay. So the best way you can do it is with this matrix multiplication method, right? So let me open up. So that's the best way. So it will take less time also. Uh, but you have to do a lot of matrix multiplication. I thought it would be easy. This data set is not that much big, so be nice. But the thing is, you have to do it by hand. That's the main challenge. Duplicate. Oh, sorry. This is week 3. See this explanation, right? See this theory. I guess it is already taught in the class. Just revise this one once again. See, you have to place your x like this. So there are two x columns, two x values, x1 and x2, right? So you'll have two columns, right? And I guess there is only 5 values. 1, 2, 3, 4, 5, 6 values, right? So let's just do it. Let's just try to compute these values and see whether it coming to be 4.05 or not. So can someone like tell me this x value and y value as I'm writing in the notebook? Okay, just tell me uh, x equal to what? Tell me all the values of x1, x2. That will be fine. X1, x2
X1 is 1 minus 1, 2
minus 1.
minus 2.
So you are telling x1, x2, right? X1, x2, x1 this fashion.
Oh, only X. Okay, X1, X2. I will tell that. 1, 0.
1, 1, 0,
No, from beginning it's 1, 0.
1, 0.
Second one, minus 1.5.
Point, 5.
2,
Then
1.
2, 1.
Minus 2, minus 1.5.
Minus 2 minus 1.5.
1, 1.
1, 1.
-1, -1.
-1. So there are how 1, 2, 3, 4, 5, 6 values, right? Now see this theory. So we have to put all the x1, x2s here and then a one column for beta 0. Okay, this one column is actually for beta 0. So I have to put this one value after all the rows. So this is how you are supposed to write, like compute this in exam as well. So it's the np dot array, just so that I don't have to multiply it by hand. I just cast it to, sorry, not array. I can cast it to np dot matrix by x, right? So and then I have to put another bracket here. Yeah. Okay, you get the matrix formation, right? Now what is the y matrix? And
Is 2.65.
see the shape, it should be a column vector, right?
Yeah.
So yeah, 2.65 and then
-2.05,
minus 2.05,
1.95,
1.95,
0.9,
0.9
0.6,
and 6, sorry,
1.45.
0.6. Last one is 1.45. 45. Okay, so 1, 2, 3, 4, 5, 6 values. Now let's just do this multiplication: x transpose x inverse, x transpose y, right? So we'll just copy this line of multiplication and get all the values of, sorry, not, okay, np is not imported, so you can just import np, just paste it x, so sorry, this would be capital X. So this is the value of what is the format of these values? Beta 1, beta 2, beta 0. Okay, so the beta 1 component is this, sorry, beta 2 is this 1.72, beta 1 is minus 2.27, and beta 0 is 0.91. Okay, so what is the equation in that case? So you can just multiply with this, so, and it's, so you have to just see there is only one inverse computation. Okay, which is mostly easy to compute, but you have to use your rough copy for that. And with these videos, let's just go with what is the, right? Okay, with this equation, so y equal to sorry, lambda, and see how you can write equations like this in Python. X1, x2, we have beta 0 to be this times so beta 0 plus beta 1 times x1, so this will be beta 1 uh, plus, let's just bracket it, plus this times 2. Okay, so y of what is the actual value we will be trying? 0.5 minus 1. So 0.5. Okay. So did we put all the data correctly? Minus 1, 0, minus 1, 0, 5, 2, minus 0, minus 1, 0, minus 1. Yeah. And these are 0, minus 2, 5, 9, 5, 6, 0, 1, 4. Okay. Okay. So it is okay. So maybe this one is, it's just reverse that. Yeah. So the matrix form in so this is, so the weight matrix for If let's say I have multiple values, right, it would look like this. Just yeah, so beta 1, then beta 2. So if I have multiple values, my weight matrix would, so for this example, my beta 1, beta 2 matrix would look like this, and my let's just write it x11, x12, x13, x14, x15, and after this I can have another x21, x22, x23, x24, x25. Okay, so now my oh sorry, let's just not have these underscores. Okay, so your the equation would look like so their matrix formation would look like this. So beta 1, beta 2, beta n up to beta n, and then at the end you have beta 0. Okay. So now if I just put that equation, it becomes 4.0527. We just round it to 2 decimal places, so it becomes 0.44. Sorry, 4.05. Okay. So just you have to do this multiplication with the matrices. Okay. You get
Can
the
you discuss the third question as well, sir?
which one? Third question.
First question. First question, sir.
Okay. So which of the following is or are
First question last.
unsupervised? First and the last. Okay. So which of the following strata are unsupervised learning, right? So so there is no target or label involved in which option, let's say. So sorting a set of news articles into 4 group categories based on their titles. So it's because it's sorting it to 4 categories, right? So it's basically creating 4 groups of newspaper based on newspaper articles. So it is a clustering problem. Okay. Now, forecasting the stock price of a given company based on historical data. Okay, so forecasting the stock price of a given company based on historical data. So this is a supervised learning task, right? Because you are from historical data, you are trying to predict what will be the next day, like tomorrow's stock prices. Okay, so what becomes feature in this case? So feature will be whatever, let's say from the last 5 days the stock prices, and the label would be what will be the stock price tomorrow. Okay, so from the historical data we can cut out these type of pairs and train a model. Okay, so it is a supervised task. So now the third one, predicting the type of interaction, positive or negative, between a new drug and a set of human proteins. Predicting the type of interaction between a new drug and a set of human proteins. So from previous data, we have this whole huge data set of human proteins, how they interact with drugs. Okay, so based on that data set, we can train a model which can give us a estimate of whether this drug will be impacting us positive, in a good way or in a bad way. Okay. So this is also a, see, I have so like told you, right? This forecasting, predicting, these two things, if it comes in your if it comes in your options, then it will be a kind of supervised task. Now, identifying close uh, k-knit communities of people in a social network. This is identifying close k-knit communities, means you just building a kind of group. Okay, so this is an unsupervised task. Now, learning to generate artificial human faces using the faces from a facial recognition dataset. Learning to generate artificial human faces using the faces from a facial recognition dataset. See, whenever this is, you are actually using the data to learn the pattern in the data and predict a new type of. So this one would be also correct. Okay, why? Because maybe you have heard of these generative models, right? That trained on, let's say, human faces, GANs, right? GANs. But they are also semi-supervised. So how they are semi-supervised? So they are not completely unsupervised. Okay, so there are semi-supervised models. So where you get the data, so where you, let's say I give X, okay, and it tries to predict whether, let's say, it tries to generate a face similar to the distribution I have given the model. Let's say a face data set, right? I can give that data set to a model. It tries to generate new faces that belongs to the data set. Not like you cannot find those faces in the data set, but it belongs to the same distribution of faces. Okay, and there is another model called this critic model, right? So generator and this critic model. Critic model, what it does, it tries to predict whether that face that model has generated is fake or true. So how it knows that? How it knows that? Because it has this supervised training of all the, let's say, all the faces that are in the data set. It considers them as true. Whatever the model has generated, it considers them as false. Okay, so it has this supervised training loop with the critic, and based on the critic signal, the generator tries to fool him, right? This mechanism is there for facial recognition, like facial generation, facial image generation from a data set. Okay, so this is a semi supervised task. It's not completely unsupervised. See, GAN is semi
Sir,
supervised or unsupervised.
sir, can you hear me?
Yeah, go ahead.
So since you told that it was semi-supervised, I actually didn't choose that option, sir. But in the answers, they have given that as one of the options.
Okay. So learning to generate facial human face from recognition data set. Okay. So because but you see that learning to generate human faces using faces from facial recognition data set. Uh, mm, See, in all the methods, right? We can actually use that X data uh, as a target for that equation. Okay, and also I guess here also they are saying that GAN is considered to be an unsupervised learning task as long as that critic model doesn't have labels involved. So if you are only training this true and fake, that's a pseudo label. You are not giving it which type of face it is, right? It's a pseudo label, and it is like you don't have to. So it's a complicated problem actually. Wait, let me just wait. GAN architecture. So why it is supervised, and when it will be like semi-supervised, it's actually a bit tricky thing. Okay, okay, let me just go with this
So
image.
for that, I have a doubt related to the
Yeah.
same question itself. Sorting the newspaper titles can be done in an unsupervised way also, no? We don't have to give information, it will automatically group based on words inside, no?
Yeah, but that is based on the title, right?
Yeah, but title means title will not be, there is no classification based on title. There will be different titles. So I can say it is news, international news. I can say it is like local news. Like that, it will automatically see the words inside and group, no? We don't have to give any labels for it, no?
But see, here it's kind of all about the language, how it is written, right? So it can be like
Yeah, but
the
these
title.
actually
Yeah,
the option which she just asked, and this option are very ambiguous options.
exactly,
So you can do
exactly,
it in this way and that way. I felt so when
exactly.
that's why I selected also the option, and for me also after thinking only we'll select these options. But
Yeah.
it was wrong for me also.
Yeah, so it's like it's very ambiguous. That's for like true. So I guess this in this case, one can like, let's say, argue with you that okay, if I just give you the titles and tell you based on the title whether it's a let's say news article or either it's a sports article, you can just group the like four articles, right, into four categories. So news group, and then
No,
so in that case, I am
if
giving
you
you
don't give that, if you, sir, if you don't give the topic also, based
exactly.
on the words, it will be able to group, no?
Exactly. So that is kind of a supervision you are getting. So the title gives you supervision of how to group them, right? So
So title
like,
is only one of the data related thing, no? It is not any label, no?
no, no, it's like see, the title gives you the explicit information of how to group it, right? So there is no learning happening. So based on the title,
No,
you are
but
grouping.
the title is not the class identification. The
Yeah, it's
exact title name is not the class label. It will be a different thing. Class
no,
label may be
no,
sports and the title may be something else. So the title and class
yeah.
label will be different only.
So it can be same also. Let's say there can be this sports markings in the title as well, right? If there is this sports, say for example, if the learning task is like this, if you find sports keyword in a title, put it in a group, right? So I guess there is, so obviously it's ambiguous. You can also think of it as an unsupervised problem. That's true. Okay, but based on their rationale, I guess they have considered that okay, from the title itself, you don't have to compute
So
anything.
when there are
You can just
questions
start
like
it.
this which are ambiguous, I think they should consider it so that because we are also starting to learn only, no?
Yeah, yeah,
So
yeah.
if I mean,
Yeah, so the way out, so for these cases, right, it can always happen like many times that like you will see in the coming weeks as well. Like there are always this type of a question where you will find that there is a logic of putting this in the right answer key, but it is not there. So what is the best way is to report these ambiguous options to the PMRF coordinator. Sorry, no, so to the NPTEL coordinator of this course. Uh, and like basically put the query in that Google group you have. Okay. That okay, I think this can be also an option for unsupervised learning with this rationale. So please
yes, sir, yes, sir.
yeah, please mark this question and
Okay, okay, sir.
consider, yeah. So if you
So
just
the
put
Yeah,
a
okay,
last
sir.
question
rationale,
also,
yeah, go
Yeah,
ahead.
so
yeah,
the
I
last
also
question
face
is
same
also
problem. Last also.
Last also, right? It's very much ambiguous. So learning to generate faces, we can think of two models. So two model can does that. One is this GAN, okay, generative adversarial networks, and one is this autoencoders, variational autoencoders and autoencoders. Okay, so not exactly autoencoders, variational
No, no, not
autoencoders
last
specific.
option, sir. Last question.
Okay. So so just to conclude with this question, the last option is also a bit ambiguous. So this the GAN, right? They are considered unsupervised. So yeah, we can put it here, but always let's say for this this variation autoencoder, right? In that case also it is kind of unsupervised, so, but there is always a semi-supervised like flavor to it. So it's a bit difficult
so
in the which
how
one?
to approach these types of questions so that they could include these as well as
So
other
so it's
options.
so it's like it's all about how you are just striking out which are not, right? It's also whenever you have an ambiguous option, right? So you have to think on it. That's it. So you cannot improve these questions like drastically within like by following some strategy. So it's like striking
So what I
options
mean
out.
is that approaching the NPTEL officials regarding to consider
Oh,
this
I
option
guess
as correct.
okay. So what you can do, you have a Google group, right? Where you can put queries for this course. You don't have it. Wait, let me check. There should be a
No, it's
Google
there.
group. It's there, right? So just put, uh, yeah, just put everything there. Put your doubts there. So the regular TS usually monitor that group, this group, right? Discussion for forum to introduction to machine learning. You can just put your doubts here. Somebody has already proven, like put some doubt here, right? Yeah, here. See, someone has already put some. So dear student, the task where you provide explicit labels called unsupervised learning problems, this answer you need to find. So A and C, simple task in task involving temporal data, involving clustering people based on social network interaction, is generative task used only for not generative task that uses only faces, not the labels. For facial recognition, learn how to generate faces. Okay. So I have
Actually, in the
so,
first week lectures, the generative was not covered also in any of the lectures.
okay, so you can just approach them with the question that okay, we don't have enough knowledge about this generative model, so can you just strike that question off from our assignment? Okay, so just like talk to them. I guess they will solve it. If you have this type of doubts, right? Whenever you have this type of doubts that if a option seems to be very ambiguous and somebody can put it as a correct option with some rationale, just put that in that group so that they can like correct your evaluation. And they usually do that. So whenever they find that okay, some option is very ambiguous to a lot of people, so they usually mark that question as ungraded or graded for everyone. Okay. Now the last question.
Okay, sir.
Yes, sir, got it, sir.
Okay. Which of the following statements are correct? So on a given training set, the mean square error of one is always of like first option is always less than or equal to that of two. So this is mean square error type one and mean square error type two, I guess. Okay. So one is likely to have higher variance than two. So MSC type 1 and type 2. Right. Okay, so this one I am a bit
Sir,
confused.
type
Okay,
type
so it
1
is
bit
type
equation is
1.
given C. See the y is equal to beta naught beta 1x. That is one.
In the same
And
question.
Yeah, y and y are given.
Okay. So type 1 and type 2 equations are given where?
Yeah,
see,
y one and two options are
In the
there.
question, sir. In the
Under 10.
question.
Yeah, in the question itself.
Where I cannot see that
10th question.
in the
10th question. Suppose that
okay,
we
okay.
train.
Okay,
Yeah,
okay,
that
okay.
is
I missed that thing. So suppose the training the okay, suppose that we train two kinds of regression model corresponding to the following equation y equal to, so this is a linear model and this is a quadratic model. Okay, so you are also considering the square components of the x's. That's the quadratic fit. Okay, so which of the following statements are correct? On a given training data set, the mean square error, okay, one is always less. The mean square error for one is always less than or equal to that of two. Okay, so no, I guess the true option would be uh, like based on the data set, obviously. Okay, so they didn't mention any like whether that data set is linear or sublinear or let's say super, they didn't mention anything, right? So unless you have understanding of the data, you so one thing is uh, this model has better capacity, right? Because let's say if I want to represent y1 with this model, I can just put beta 3 and beta 4 and beta 5 to be 0. That boils down to the first equation, right? So the second equation is more powerful than the first one. So what I can conclude from the data without knowing how the data looks like, right? I don't know how the data looks like, but from these two structures, I can infer that okay, from y1 I can easily go to y2. Sorry, y2 I can easily go to y1, but from y1 I cannot reach y2. So if the data set is more complex, I cannot fit it with y1, but I can fit it with y2. Whereas if it is simple, I can easily fit it with y2, and y1 also works because so if I just put b3 and like beta 3, beta 4, beta 5 to be 0, it boils down to y1. Okay. So with that rationale, what I can say, which of the following, so in all the cases, this MSC error would be less. Okay. Or less or equal to the one. So it should be, so this should be less or equal to this. So whenever it has the data has more complexity, it should be less because this y1 model cannot fit the data, and whenever it has less complexity, they both will be equal. Okay, so let's just go through the options. 1 is always less than or equal to of 2. No, it is not correct. 1 is likely to have a higher variance than 1. 1 is, and which one has the higher variance? Higher variance means what? How much it varies according to him, like that data, right? According to its prediction, right? So y1 would have always less variance than y2 because it is a quadratic model. So it will vary more with respect to a linear model. Okay. Okay. And like how can you visualize these two graphs? So because there are two values x1 and x2, right? So y gives the equation of a plane, and y2 gives the equation of a metafold, which is this. It's a quadratic metafold, so it looks like a like bowl. Okay, bowl of let's say like normal bowls that we use for eating, right? So y looks like a bowl with this form, and so y1 looks like a plane. Okay, so obviously this y2 have more variance, so the second of this option is not correct. So y2 is likely having higher variance than 1, that is, this is correct. If one overfits the data, then 2 will definitely overfit, exactly, right? So if 1, which has the lower complexity, overfits the data, then 2 will definitely overfit because 2 is more powerful. 2 has one like within these values, right? So you can always approximate whatever is approximated by 1 with 2. So this is also correct. So if 1 overfits the data, then 2 will definitely overfit. Okay. If 2 overfits the data, then 1 will definitely underfit. So if 2 overfits, then that means what? That is the quadratic component. So the
So the
linear model
question is,
cannot.
option is if 2 underfits. If 2 underfits.
Yeah, if okay, so
The
if 2
option.
underfits, yeah, that's obviously correct, right? So if 2 underfits the data, that means it's more like let's say it can be exponential or something which cannot be captured by a quadratic equation also, right? So it's more powerful than a quadratic form. So that means obviously 1 will underfit also because 1 is just a linear model. Okay, so this one is also correct. So these two, yeah, these two is there. Okay. And there is another option we can think of, right? If that's an ambiguous option, obviously, if 2 overfits the data, whether 1 will underfit or overfit, right? So because 2 overfits, that means it's a quadratic. It overfits means what? It touches all the points, right? Touches all the points in the data set. So that means the data set is a quadratic data set. Okay. And 1 will obviously either underfit, okay, or it may fit properly as well based on how complex the data is. So that's an ambiguous kind of option. They have omitted it, I guess. That's good. So there is no ambiguity in these options 1, 2, 3, 4. Yeah. Any other doubts? Guys? Nobody.
The last options, vice versa will be the false option, right, sir? Like
Why
in
the?
case if one, for example, if one underfits the data, then two will definitely underfit as a false option, sir.
If 1 underfit the data, the 2 will may under it would mostly I would not say overfit. It will mostly approximate the data more, right? Because one has less power in terms of or less capacity in terms of how much it can cover. It's a linear planar model, and this is a kind of quadratic model. So if one underfits, I cannot say whether this one will overfit or go properly. So there are two options. It can approximate the data properly, or it may overfit. Okay. So that's an ambiguous option, obviously. So they didn't have so they didn't give any type of these type of options here. That's actually good. So here the options are very clear. Okay, because this is a quadratic model, it has higher variance. If one underfits the data, then it like two definitely overfit because this so it can overfit or it can okay. So this option is bit ambiguous. So we cannot guarantee that it will overfit. Okay, if one underfits the data, then we cannot guarantee that this 2 will overfit. Okay, but they have mentioned it like 2 will definitely overfit. We cannot guarantee it.
Sir,
No, but
what
actually, sir, it is okay, I think, because if 2 underfits the data only they've given. So if 2 underfits, then definitely 1 will underfit, no?
Yeah, but this option, right? If 1 underfits the data, then 2 will, or 2 will definitely. So if, okay, no. If 1 overfits, that's fine. So if 1 overfits, right? That means 1 is already touching all the points. That means 2 will definitely touch
sir,
all
I'm
the points.
asking hypothetically, sir. I'm saying it hypothetically, not the given options. I'm asking that if 1 underfits the data, then will 2 definitely underfit?
No. 2 is more, 2 has more capacity, right? So it will not definitely underfit. It will either go properly or overfit. Those two possibilities are there. Okay.
So we can say this on the basis of the complexity of the model, sir.
Yeah, exactly. So actually there are like all three options can be possible. So let's say my data is exponential, okay? So in that case, my quadratic model will also underfit, right? So that in that case, I have to know the shape of the data. So, okay, if 1 underfit, I cannot say anything about whether 2 will underfit, overfit, or go well with the data, because unless I know the shape of the data. Okay, because if 1 underfits and my data distribution is exponential or something like that, so that 2 will also underfit. That also one possibility. If 1 underfit and 2 and the data is, let's say, quadratic, then 2 can go well, right? And if, let's say, the 2 can touch all the points, then it overfits. So there can be three possibilities: underfit, overfit, or go well. So that's why that option is not there. You get the point, right?
So what does go will mean, sir?
Wait, what one?
The third option that you mentioned, what does that mean, sir?
Okay,
You
third
say it's
option.
underfit and overfit.
Okay, 2 is likely to
No,
have a
sir,
high
the
one means.
term that you told now, sir, go will.
Can you repeat? I'm not able to understand.
Sir, you told that there are possibility of three
Three
things to
cases,
happen,
right?
no, sir. What was the
Yeah.
third thing?
What was the
Third thing that you told that will
third thing?
happen besides
Yeah.
underfit?
First one, second one is clear. So it can underfit, go well, or overfit as well. For example, if the quadratic data doesn't have any variance, right? It can touch all the points. So it can easily touch all the points. So it can overfit as well.
Yes, sir,
So
got it.
underfit, go well, overfit. Yeah. There can be three possibilities. Any other queries on this? Is week 1.
Question 7, question 6 also.
Question 6. So consider the following data set using a neighbor regression model with k equal to 3. Predict the value of x1, x2 equal to this. So what you will do? You find the closest pairs, or closest 3 pairs, with like what is closest to this, and get the average of their y. Right? So do I have to?
Yeah, we have
Okay,
calculated
sir.
that. The answer is 1.733. Most of us are getting that same.
Yes, sir, that is what.
1.733 is the answer. We have calculated.
Yeah, that's what I also got, but the answer is incorrect.
Yeah, this is incorrect.
133 they have given.
Actually, they have
Option
rectified
is
it
incorrect.
that it is 1.733.
Okay.
It has
So
been
that is
No,
rectified
but
that it is
this is still
1.7.
marked as wrong for me. It is still marked as wrong for me.
no. See.
I think
See.
someone asked only today, so
Okay. So see.
It
Okay,
has
okay.
been rectified,
Maybe
so
I'm
Okay,
don't
trying to
okay.
worry.
say, maybe it was discussed.
Okay, so I guess this will be rectified. It may reflect on your assignment evaluation like quickly, or they will just mark it whenever they will take the grade. They will mark it as ungraded, or let's say graded for everyone.
Okay.
Okay, so we'll see. Any other doubts on
I
week
have a
1?
question on question number 2, sir.
Question number 2. Which of the following statement about reinforcement learning are true? So while a learning policy,
Sir,
while
sir,
the, yeah.
Sir, why can reinforcement learning be used in an autonomous driving system? Is it not very risky?
Mm, so why the question is why cannot can be used in
Why?
a
Why the last option is correct? I'm asking.
Hmm?
Is it not very risky of using
But
reinforcement learning in this?
no. That is true. But see, current autonomous driving cars, right? They have this reinforcement system built to them. So they what they does what so they try to move the car as steady as possible. That's their reward system. So the car should be as steady as possible. Might should not hit any car. It's just like playing a game. Okay. So most like that's why what happens that let's say whenever you are driving a Tesla, right? The car can follow the road's trajectory. It can drive you to your to your destination. But the thing is, you have to put your hands in the like steering wheel, right? So whenever it like get away from the balance, you can just kick in. Okay. So it is a
So on
reinforcement
the
learning task. Yeah.
so
Go
on the
ahead.
basis of that notion, the first option should be correct then, sir.
No, the last option is also correct. So there is this RL loop in a driving autonomous driving system. What is objective are to keep the car as steady as possible and should not bump into some other car or some pedestrian or some other objects. Okay.
Yes, sir.
So
I don't have any problem with that. So I am saying if the goal of a reinforcement learning agent is to maximize the reward for every next step, then the
mhm.
first option of the second question should be correct.
Which while learning a policy, the goal is to maximize the reward for no, not the current step. So see, there is this concept of return in reinforcement. So if you are only maximizing the current step return, that is a greedy policy, right? It's a greedy policy you can follow. So you are only concerned about the first step reward. But what reinforcement learning does, it tries to maximize the return. What is a kind of what you can say addition of all the like future reward steps. So it tries to estimate if I follow this, what will be my total reward up to let's say next 5 minutes. Okay, this concept of return is there. Return in you can see the equation if there is any. Yeah, this one, right? Summation of all the rewards from t equal to 1 to t. So it tries to maximize the entire kind of span of reward. It's not trying to maximize the initial or immediate reward. Okay, so that's why the first option is not correct. Sometimes it's also represented as value function. So whenever you are taking an action, you are trying to increase the value function, not the reward. So what the value function means, it means if I do this, I will get up to my end of the trip, right? I will get total reward as this. Or if I let's say choose B, option B, my total reward will be let's say less than A. So I will definitely choose option A. Okay. Or let's say action A actually. So it doesn't
Yes, sir.
try it doesn't try to optimize the current step return. It tries to optimize the total reward it will get from that step, which is known as return. Okay, you will see that term when there will be reinforcement learning. Yeah, week one. It should be covered later on, I guess, when there will be more topics on reinforcement learning. Okay. Okay. Any other doubts on week
Yes,
one?
sir. Yes, sir.
Go ahead. Go ahead. Any other doubts? So we can move.
Sir, can you discuss week two, sir?
Which one?
Week two,
Which
sir.
one? These 3 and 4. So you want to discuss with 3
The
and
week
4?
two, sir.
Week
Week?
two, sir.
Okay, I guess there is
Excuse
some.
me, sir. Excuse me, sir.
Go ahead.
Sir,
Go
in the
ahead.
last question,
Uh-huh. Last
uh,
question.
when would be the optimal, what kind of problem would be optimal to use quadratic regression?
So
I'm just
quadratic
asking.
equation. See, you can just this. So there is this 2D graph plotter, right? You can see what that function look like actually. Then you'll be graph plotter. Yeah. So y is equal to x1 plus x2. Okay, so I can only do one-dimensional quadratic equation in this. Let's see, graph 2D. Okay, so 3D. Wait. Yeah. Now y is equal to uh, x1 plus x2 plus x1 x2 times x2 slider for all, and then plus x1 square plus x2 square, right? And then extend to 3D. Right, so it's like this. Extend to 3D, x1 plus right, so it's like this. Oh, sorry. It should be z equal to, and these to be x and y, not x1, y1. X and this should be y. So let's just put others too. x1, sorry, x plus y plus xy, x times y plus this. So your data would, if your data looks like this, okay, if you have points with this type of let's say shape, right, then it can overfit. Okay, whereas the other equation is what? Z is equal to some constant, let's say 1 plus, here I can also put a constant 1 plus, right, x plus y, right? So in that case, you can only fit this plane. Okay. So if your data is within this plane, you can fit it. And if your data is something like this, forms a quadratic bowl-shaped form, then you can fit with the second equation. Got it?
Yes, sir.
Okay. Now we can move to week 2 for the drive is, yeah. So we were discussing week 2 here. So I guess you don't have any doubts here in the last run's assignment questions, right? There are questions of this principal component, similar type of error. See, that's why I'm not sharing with you these the assignments a priori, because there can be multiple questions that would be repeated in this term as well, right? So the rule is basically go with 50% repetition from the last run. Okay, so that's why I'm just sharing this week's question as the weeks are folding along. So just to like not leak these assignment questions beforehand, because they will be very much overlapping. Yeah, go ahead.
So can we discuss week 2 assignments, sir?
Okay.
This
Week 2 assignments. Yeah, go ahead. So so any doubts, or I can go with serially discussing all the questions.
if possible, just brief answer for all the questions.
Okay, so in a linear regression model, y is equal to this form. That's exactly what this like this. What is this violet graph looks like, right? This is the same, but okay, this is the same form. And xp is the how much dimension you have. So if you it has p dimensional plane. Okay, so in a linear model, this what is the purpose of adding an intercept theta 0? So you can see actually, I can just put a constant a and put a slider here, right? Now see what a does. This is what a does. Okay, so yeah, see, it is actually moving the plane at the z axis. So you see if it actually, so let's just remove this equation, you can see it more clearly. So see, this is my initial plane. If I just let's say theta, okay, and then put theta here as well, or let's just put slider for theta. Slide, you can put slider for theta. No, let's go for a. Okay, so what the a impacts is, it actually means this intercept at z, this intercept at z. Okay, so if I just move it, see, it will move the whole plane. Okay, so with that knowledge, we will see to increase the model capacity. mm, Not exactly, okay, because it doesn't increase the capacity, it just helps it to move upward downward. Okay, if you just normalize the data, even a plane passing with the zeroth or 000 or origin can also like fit the data. Okay, okay, to account for the effect of independent variables, no. To adjust the baseline level of independent variables when the when all predictors are 0. Okay, yes, yes, yes. So to ensure the coefficient of the model are unbiased, no. So what it does, it actually ensures, so whenever let's say other predictors are 0, right? Let's put, let's say b1 and b2 here. So what it does, we can put sliders for all of them. Let's just have them to be 0. Okay, let's see what would, yeah, b1 is 0, b2 is 0. Now see what it does. It actually, yeah, move it in the y axis. Okay, or here in case of this, it is y axis. So to adjust the baseline level of the dependent variables when all predictors are 0. So whenever this term theta 1, theta 2, all these things are 0, in that case it just controls the baseline. So that's what exactly what is happening here, right? It controls the baseline.
Sir, what is the need for us to control the baseline, sir?
So baseline is what will be the value for the your what your function y when the other components like this other x predictors, means other predictors except for the bias term is 0. Okay, so in that case what it does, it controls the baseline, so the base value of the function. So baseline means what, the function would not return a value like lesser to that. Like baseline means that in what it can be lesser to that like based on whether x value is negative. Okay, so baseline means at least there, so if all the predictors are 0, okay, at least this much value will be produced. So a is the baseline thing that gets, let's say b has some component that it get tilted. Okay, and the baseline is also
So
changed.
basically, when we
Yeah,
are reducing all the other predictors to 0, to avoid the output also to be 0, we are having a
yeah,
baseline, sir.
yeah, exactly, that's the whole point of having theta 0. Yeah, the third question. Now
Yes, sir,
let's
got
move
it.
to the second. Move to the second one. Which of the following is true about the cost function, objective function used in linear regression? It is, so linear regression objective is mean square error, right? So this MAC. So it is a convex function. Okay. It always minimized at theta equal to 0. Theta means here. They didn't mention what is theta. Okay, theta maybe here. So I'm not sure about this option. It always minimized at theta equal to 0. Okay. So it measures the sum of squared differences between predicted and actual values. That is what MSE is, right? And it assumes the dependent variable categorical. No, it's a regression. So it will be a real value. So yeah, by the rule of striking out options, I am more confident with this one. And that's what is the right one. Okay. So which of these which would most likely indicate the lasso regression in a better choice than ridge regression? So what is lasso and ridge? Ridge minimize L2 error and lasso regressions minimize L1 error, right? So L1 means it tries to minimize the modulus of the mean absolute error, and like ridge means it tries to minimize the uh, weight also, right? Weight uh, L2 norm, right? So so it tries to minimize L1 norm of the weights and L2 norm the weight. Based on that, we can classify it as a lasso or a ridge. Okay. So which type most likely indicate that lasso is a better choice than a ridge. So lasso is used when lasso is used when I have to set these theta values closer to 0. So I am basically selecting features. Okay. And for reach, it is hard to make a weight value to so it is hard to push a weight value to be 0 because we are minimizing the square of it. Okay. And square dies quickly than absolute. So after some time, absolute will give me more signal than the square of that weight, square of that parameter. Okay, whatever you can say. So theta 1, theta 0, theta 1, theta 2, theta 3. These things I am talking. So for lasso regression, we just take their L1 norm, and for ridge regression, we take their L2 norm. So L2 norm, we cannot push them towards 0, which is harder than L1. So for L1, you can push some parameters to 0, so that those features will be cancelled. Okay. So which of these would most likely indicate the lasso regression is better choice than ridge regression? So all features are equally important. So that means uh, all features are equally important, right? So you cannot use lasso, because lasso, what it does, it tries to strike off some features, that okay, we put the associated weight with that feature to be 0. Okay. So when the features are not equally important, we can use a lasso. Okay. Okay. Features are highly correlated. So features are highly correlated, that doesn't make any sense, because if I have one, so if features are highly correlated, in that case, I can strike off most of them, right? Yeah. So this option seems promising at this point. We'll just keep it in our bucket. Let's see, because it says multiple select, the multiple
So
choice.
wouldn't it be
Multiple select.
rich more suitable for the second option?
So why? So that, see, if the features are highly correlated, right? So we can strike off which are, let's say, so if x1 is correlated with x2, I can only have x1. Okay. And I can estimate x2 with that x1 only. So in that case, I can put the associated weight with x2 to be 0. So that can be achieved better with lasso than ridge. Okay. So we'll just put this in our bucket. We'll see if some other options is also correct. So
And
most
here only
feature
one
have
option
small.
was possible also for
Yeah,
the
yeah.
design.
Yeah, let's go to the other options. See, most feature have small but non-zero impact. Most feature have small but non-zero impact. In that case, if I go with lasso, it can turn off some features, right? So it will be better to go with reach. Small but non-zero impact. I have all the features which have small but non-zero impact. That means I don't want to strike out some features. That would better to go with a ridge regression. Okay. Now last option. Only a few features are truly relevant. That's what lasso does, right? It strikes out features which are not important. So actually these two are correct. Okay. But anyway, this is exactly what lasso does. This is what we can infer from it. If let's say the features are highly correlated, we can strike out some features, but they can always have a, because they're highly correlated, right? They're not exactly same. So they can always have a non-zero impact. Okay. So it is partially true, but if you just go and argue with this option, they can say that, okay, see, they are highly correlated, but it is kind of similar to the third option. Most feature have small but non-zero impact. So here we can say most feature have not small, we cannot guarantee small, but has non-zero impact. Okay, but anyway, so this is conclusive. So it is exactly what lasso does. This is a bit convoluted, I would say. In case
So
of
highly correlated means
highly correlated means you,
yeah.
let's say one feature is X and another feature is 2X, right? So those two are like X and
Yes,
2X
sir.
are highly correlated. Okay. So this is a bit tricky option, but better to go with this one. Okay. So this is what exactly lasso does. And you can argue with the second option, but it is obviously a kind of like topic of discussion. Someone can say, okay, if they're even if they're correlated, they can have just like very small impact on the prediction. So if I go with lasso, it can reduce my performance. Okay. Now let's go with
Sir,
4.
sir,
Yeah. Go
sir,
ahead.
excuse me, sir.
Yeah. Go ahead.
Sir, once again, please explain what is this lasso and ridge relation, sir?
Yeah. So see, lasso. Let's just go with equation. Lasso and ridge. Oh. You can, where is the equations? It's an equation. Yeah, I guess. Yeah. See, this is the equation for this. Let me zoom it. Okay, cannot zoom it. Just open it up. Okay. Okay. See, this is the lasso. First one is the lasso one, and the second one is the your reach. Okay. So, you can. So, it's talking. Just mute this guy. Okay, so for lasso, we can see that it is trying to minimize the modulus of the beta parameters, right? And for reach, we can see that it is trying to minimize the square of the beta parameter. That's the difference. So that means what? Modulus becomes closer to 0 than, like, modulus becomes easily closer to 0 than square, because square dies quicker, right? From modulus. So if I'm going closer to 0, I mean, basically what I'm doing, I'm striking off features. Okay, this feature I don't need, so put the associated weight to be 0. So these type of things we can achieve better with reach. And when the features have, let's say, some like additional, so if all the features have small impact or a marginal impact on the prediction, then going with reach would be a better option. Okay. So yeah, so this one is a bit tricky, this option, but this is what exactly lasso does. So it's better to go with this.
May this question be asked in a reverse manner, like which of these would most likely indicate ridge is better than?
Yeah, so reach will be when all the features have like small but non-zero impact.
Okay.
Okay.
That will be the answer for
Yeah.
reverse. Okay.
So basically, you will kind of weight the features based on their impact. So it should not be
Because
0
if lasso is
exactly.
better, then only few features are truly relevant will be the answer.
Exactly.
Like complete. Okay.
Exactly. Okay. Which of the following conditions must hold for the least square estimator in linear regression to be unbiased. So which of the following condition must hold for least square estimator find in linear regression to be unbiased? So let's see. The independent variables must be normally distributed. Not exactly. So even if they are normally not, they are not normally distributed, we can independent variables are normally distributed. No. So independent variable mean the x's, okay, the x values, x1, x2, all these, they should not be normally distributed, rather they should be uniformly distributed for a good linear regression model. What it means, you don't have like, so all the density in like in some point, let's say normal distribution means what, it has more density at the middle and lesser density at the sides, right? So for a 2D case, right? Let's assume that so having a normal distribution would be like your all data points are basically centered to one specific part of the graph of the 2D xy x1 x2 plane, and other parts you have just sparse points. Okay, mostly all the points are densely packed in one small area. So we don't want that, we want a uniform distribution, so all the part of the x1 x2 plane have data. Okay, so this one is not the answer. The relationship between predictors and the response must be non-linear. It is, so it's a linear regression model, right? So this is also, if it is non-linear, then it will be underfit, right? Now the error must have a mean of 0, that we can consider. So if the error have a mean of 0, that means we have like fit the data properly, right? So in most cases, so what linear regression means, let me just go with simple data, right? So what you are trying to minimize in linear regression is to, yeah, so let's go with this graph. These error components, right? Whatever you are missing from the, like which much distance you are basically missing from the actual data point, that that average you are trying to minimize. That is what linear regression or least square regression means, right? You have to be this distance of distance between the actual data and the predicted data. If you just square it, that should be least, at least, right? So yeah, this should be correct, and the sample size must be larger than the number of predictors. So that means what? Uh, the sample size must be larger than the predictors. Yeah, so this is also true. Okay, because no, so not true. If the sample size is not larger than the predictors, you cannot even like have a linear regression model, right? So let's say I have uh, so it's easy to explain it like this. Let's say I have um, only x and y, two-dimensional regression. Okay, I need to predict y from x, and I only have one data point. I cannot build a linear model, right? At least I have to have two data points. Okay, right? So if my number of samples are less than the predictor, so for my case, the predictor was only x, and I have exactly one data point, that I cannot build a linear model. I have to have, let's say there are n predictors, I have to have n plus one number of samples at least. Okay, so this is also, the sample size must be larger than the number of predictors. So you cannot, must be larger. Yeah, this is also true, because so it obviously doesn't help with unbiased, being the linear regression model to be unbiased. But this is like generally a fact that the sample size must be larger than the number of predictors.
But if we write this option, we were not given mark.
Yeah. So I don't know whether this option is like even correct in putting in this context. So see, number of predictors and the sample size, they doesn't go with unbiasedness of the model. Okay, it only goes with whether you can build a model or not. Okay, so whether I can build a linear model with n number of samples or not, I must have number of independent variables plus one number of samples to build a valid linear model. Okay, so I don't think this option is like even correct in putting up in this context, but anyway, this is correct. Okay, it's a fact that the sample size must be larger than the number of predictors. So yeah, so this must hold so that you can build a linear regression model, be it unbiased or biased. Okay, so in both cases, unbiased or biased, this is always true. Anyway, I don't know
What is the meaning of unbiased or biased here?
So biased means you have. So biased means your predictions are far off from the actual data, and unbiased means your mean error you have, mean square error you have, it's like close to zero. But this type of equation, yeah, like this. Biased means it will look like something like this. So when some points you have closer error, or let's say lesser error, and then for some points you have very large error. Okay, so the median, so that the mean least square error is more. That's when you say it's a biased estimate. Okay, unbiased means the average error is zero across the whole data set.
Okay.
The error is zero.
That is preferred. So unbiased will be preferred.
Yeah.
Over biased.
Okay. So when performing a linear regression, which of the following is most likely to cause overfitting? Okay. So adding too many regularization terms. See, for linear regression model, regularization, okay, too many regularization terms would actually underfit. Okay, it would not cause overfit, it will underfit. What you are doing, you are striking out features, right? You are not considering a particular regularizing means you are let's say striking out features. I don't need this feature, put that weight, corresponding weights to zero. That's what regularizing means. So it will likely underfit, not overfit. So this is not correct. Including relevant predictors in the model. Relevant predictors, so you are not putting up irrelevant predictors, or let's say predictors which are, let's say, so including irrelevant predictor to the model. Irrelevant predictor will not overfit, it will likely underfit the model. Why? Because it is increasing the number of dimensions and it is not adding up to the data set, that it is not adding up any kind of information to the data set for the predictive, for the target variable. Okay, so putting up irrelevant predictors will always underfit your model. Okay, or hurt the performance of the model in some way. Okay, that's why we do this feature selection, that okay, all the irrelevant features would be gone after the feature selection part. Okay, so this is also not correct. Increasing the sample size always help in making a model that fit well with the data, not overfit. Okay, using a smaller design matrix means this what I am not clear. And they have
the input X is design matrix.
Okay, I have to see. Anyway,
I understood it that way.
No. I'm not sure. So what this design matrix means? Okay, I have never heard this design matrix terms earlier. So okay, so they have said that including irrelevant predictors in the model will overfit the model. Okay, is it so? So I'm not sure on this. I'm not sure on this question answer. This answer. So irrelevant predictors, what it does, it basically
Sir, design matrix is basically X, the X matrix in the formula for beta 0.
Okay, so you are saying that this number of dimension using a smaller number of predictor variables. That's what this means. Smaller design matrix X means you have smaller number of X components. X1, X2. Let's say you have earlier you have n components. Now you have, let's say, n-3 components. That's what smaller design matrix means. Okay, so smaller design matrix can smaller design metric can overfit. I cannot say anything about overfitting, underfitting this with this information. But they are saying that putting up irrelevant predictors actually cause overfitting. Is it true? So I'm a bit skeptic about this option. Okay, irrelevant
Most
predictor
relevant
means
option will
most relevant option will be to use a smaller matrix. Okay, smaller design matrix. So if you just not take some features which are good, right, you may overfit the data. So I would go with this option. But how they're saying either including irrelevant predictors in the model would cause overfitting, I'm a bit unsure. We can just ask the rationale behind it. Ask in that group that how this question or how this option is true. If there is any rationale they can provide. Okay. So including irrelevant predictors means what? You are putting up features that are not related to your data, right? So that means what? You are basically like hurting the model performance. That's what we observe in actual like research or anything. If you have, let's say, like irrelevant features, that will basically hurt your model performance than overfitting it. Okay. So
no,
I'm a bit
but
skeptic.
including irrelevant features is likely to take our model to more overfitting area. Na? If just imagine, sir, we have 13 features, of which we only need 3 of them to predict what we want. So, if we use all 13 of them, then the model is likely to overfit according to our data.
No. Is it? Model will overfit with the okay. You are saying it will overfit with the irrelevant features, not the relevant features.
Yes, sir. Yes, sir.
Okay, yeah, that they can, yeah, this rationale would work for validating this. Okay, so it will only happen when the irrelevant features are more, or irrelevant that this irrelevant noise is more in your data set. Okay, so if it is less, it will basically hurt the model performance. Okay, so model had to find out some way to coping with this noise irrelevant predictor. So it will basically hurt the model performance. But if my data is mostly irrelevant predictors, that it can happen that my model overfits with to the irrelevant features. That can always happen. Okay, so that's fine. Let's 6. So we have trained a complex regression model on a data set. To reduce its complexity, you decide to apply ridge regression. So what you are doing, trained a complex regression. So it's not a linear regression model, and you apply ridge regression. Okay, so you are not trying to strike off features, you are trying to weight them. Okay, using regularization term parameter lambda. How does the relationship between bias and variance changes as lambda becomes large? Okay, if my lambda becomes large, that means I will try to push my weights further to 0. Okay, so the equation looks like this least square error term minus lambda into the square of all the parameters. So the summation of square of all the parameters. Okay, so that's what ridge regression equation looks like. And if my lambda becomes larger, then it will give weight, then it will give more weight to the L2 normalization error than the MAC. So what will happen in eventually, the MAC will not be minimized, rather the weights will be minimized more, right? So we are supposed to give an answer on how bias and variance would change. So variance will also always go down, right? Bias can, because beta term, right? That beta term doesn't have this L2 normalization. Beta term is excluded from that ridge regression component. Okay, so in that case, bias can go up. Okay, so bias is high, variance is low. Yeah, that is correct. Because bias component is not included in the ridge regression optimization function, so it can go up without affecting the ridge regression part, right? and your variance will obviously go down because you will try to put features to 0, right? Features to 0 coefficients, right? So your bias will be higher and your variance will be lower. Got it?
Sir, can you just explain? Sir, can you just explain how the graphs look like
Okay.
for problem 6?
Yeah. Problem 6, what it will look like. You cannot plot a scatter here, right? I cannot plot a scatter. We could if I can plot a scatter also. Scatter I can put. No. Okay, let's just put a normal z is equal to a plus b1x plus b2x plus b2y plus xy plus x squared plus y squared. Let's say my data looks like this. Okay, let's assume my data looks like this, and it's a complex regression task. So yeah, my data can look like this. Now my predictor, I put C. So if my predictor is something like this, yeah, this, right? Let's just have some noise, B3, which is a bit different. Yeah, let's say my data looks like this, and the brown curve, the violet curve is my data, and my regression is the gray curve. Okay, so now see what will happen if I try to put all the features to 0. Okay, so let's remove this part. So now my prediction looks like this. We'll try to get rid of all the components except the bias part. Okay, so now my prediction would look like this. Okay, it still fits the data up to some point, but mostly it is way off from the data, right? Here. Now let's strike out these 3 terms. Now my data looks like this with some tilt. B1 is 0, so let's just have some B1 component. You'll see B1 is at tilt. Okay, it still hits the data at some point, but mostly it misses. Okay, now let's put now the variance become exactly 0, right? It doesn't vary at all. But to fit the data, what it can do, see, this data has more error than wait, by A. Okay. So I have to have a A1 component for this. I want to be 1. Okay, to just make them different. So now this one has more error than if I improve my graph here, right? It has lesser average error. So that what will happen? The bias will increase to reduce the error, and my variance will decrease because I am striking up all the other components. Okay, it is not varying at all. It is just a plane. You get the point? Why the bias will increase? Because initially, let's say if my bias is less here and these non-linear components are taking care of the fit. Now if the other components are not there, my function would have less error if my bias increases and goes till here, right? It has now lesser average error. Okay,
Thank you, sir.
that's why the bias will be higher and the variance will be low. Okay, given a training data set of 10,000 instances, with each input instance having 12 dimension, each output instance having 3 dimension, the dimension of the design matrix using to apply regression in the dataset is. So let's just clarify what design matrix is. The definition of X. Okay. Design matrix, also known as model matrix or regression matrix, is denoted as X, and X is what? X is this one, right? So all the features and then the one column for bias. That's it. Really easy. So we have 12 features. So 12 x1 up to x12, right? And then the one column, one column for the bias. So it will be 10,000 instances, like x11, x12, x up to x 10,000, and for x21, x22 up to 10,000 to 12 dimensions. So x12 1 up to x12 10,000, and the one component for bias. So it will be 10,000 comma 10,000 cross 13. Okay, 12 for the dimension, 1 for the bias. Now the linear regression model y is equal to this is to be fitted to a n training data points having p attributes. Okay, let's x be n times p plus 1 vector of input values. That is what this design matrix means, augmented by ones. Okay, well, augmented by ones means you are having that bias one component as well. YB n times one vector target values, that is fine. So you have one target y, and theta to be p plus 1 time x, that means theta 1, theta 2, theta n, theta p, and at the below you have theta 0. So p plus 1 into one vector, that's fine, a column vector of parameter values. A equal to a means, okay, the coefficients are given. If the sum square error is minimized for obtaining the optimal regression model, which of the following equations will hold? Okay, so so what was their earlier equation? It is like this, right? So theta equal to x transpose x inverse x transpose y. So if I just multiply it right side with x transpose x inverse, it will be x transpose x inverse theta equal to x transpose y. Let's see whether that option is available there. Yeah, this one, right? X transpose x theta equal to x transpose y. So we are multiplying with it with x transpose x. Where is that? Yeah, we are multiplying it with x transpose x with to the right side to have this component as identity, right? So x transpose x, if I multiply it in the both side, x transpose x and x transpose x inverse will go down to identity. So now my equation would be x transpose x omega equal to x transpose y. Okay. Which of the following scenarios is most appropriate for using partial least square regression instead of ordinary least square? Okay, so this part I am not sure, but let's see. Partial least square and ordinary least square I forgot. So when the predictors are uncorrelated and the number of sample, okay, when the predictors are uncorrelated and the number of sample is much larger than the number of predictors, so in that case, so okay. Now from the context, I can see ordinary least regression. Least regression means you will consider all features to be equally important, and partial least regression means you will consider that some features can be omitted. Okay, and with that omitted features, you can regress even in a like better way. Okay, so if the predictors are uncorrelated, the number of samples are much higher than the number of predictors. Most appropriate version. So then you can use this ordinary least square regression, right? Because like losing some predictors may hurt the performance. So when there is significant non-collinearity among predictors, okay, when there is significant multicollinearity among the predictors, or number of predictor exceeds the number of samples. In that case, see, if the number of predictors exceed the number of samples, that means I cannot build a model with that, right? I have to strike up some predictors, right? In that case, partial least regression will be the obvious choice. You cannot go with ordinary least regression because you cannot build a model, right? You have less number of let's say samples than the number of predictors. You at least have to have n plus one number of samples. Okay, so this one is correct. Next, so when the response variable is categorical and the predictor are highly non-linear. We cannot say anything about this, so there is nothing you can say. Okay, when the primary goal is interpret the relationship between predictor and response rather than prediction accuracy. So if I am trying to get the relationship between all the predictors and all the response, right? In that case, partial risk regression is not the option. See what it does, it basically strikes off some predictors. The predictors features they are used interchangeably. Okay, so it strikes off some features. So but we need relationship among the all the features and the predict and the response. So we'll use for a least regression. So yeah, so this option is correct.
Actually, during the lecture, no, it was mentioned that that responses for partial least squares, we tried to find out the relationship with the response or something.
Yeah. So response means your prediction. That's it. So the predictor means your features. Response is your prediction. That's the what you can say the other two names of feature and prediction variable. So these features are also known as predictors, and this like
No,
your
because
prediction
actually,
is
when
also.
in the lecture for partial least squares, sir had mentioned that the response will be used, no, for partial least squares.
Yeah, because see, partial least square, what you do, like you try, so your goal is to put the response close to the targets, right? So partial least square regression, what it does, it tries to strike out the features that are not important. That's it. So partial list means you are not using the whole set of X, you will only use a partial set of X. That's it. But here, see, I want a relationship between all the the X's and the response. So I have to go with like ordinary least square regression, right?
Okay,
So
sir.
that no features left out is left out.
Okay.
Okay. Now the last one, consider forward selection, backward selection and best subset selection with respect to the same data. So forward selection is what you are trying to add up features one by one. Backward selection is you are trying to remove features one by one. And the best selection is you are trying to select a set of features. So the set of features can be the power set. Okay. So you can select a set of features by computing the power set and iterating over it. So power set means what? You have all combination of features, set up all combination of features. Okay. Based subset selection with respect to the same data, which of the following is true? Consider forward selection, backward selection, based subset selection with respect to the same data, which of the following is true? Okay, based subset selection can be computationally more if expensive than forward selection, obviously. So based set subset selection, what it means? You are trying to iterate through the power set, right? So you are first computing x1, x1, x2, x1, x2, x3. So the forward selection is already within the best subset selection, and then you are going with other pairs too. For example, x2, x3, x2, x3, x4, like this. Okay. So this best set subset selection is the highest computationally expensive like feature selection that you can do. Okay. Now second, forward selection and backward selection always lead to the same result. Yeah. So what third forward selection does, you try to, so you have, let's say like let's say F features, you try to add them one by one and you try to remove them one by one. That's two methods, this forward selection and backward selection. So they will usually converge to the same feature. So after that feature, the accuracy doesn't increase. Okay. So for backward selection, what is the criteria? If your accuracy drops significantly, you stop there, right? And your forward selection, your criteria is if your accuracy stopped improving, you stop there, right? Or stop significantly improving, you stop there. So we usually forward selection and backward selection always lead to the same set of like chosen features. Okay. So best subset selection can be computationally less expensive than backward. No, this is wrong. The first option is correct. Base subset selection and forward selection are computation equal. No, no. So yeah, so only this option is correct. Okay, week 2 is done. Week 3 the assignment dates are over, or you are still doing the assignments?
Still doing.
Okay, so we'll not discuss them. it is not yet submitted. Fine. So we cannot discuss week 3's assignment from the last run also. That is good. So we can. Okay, so any theory topic you want me to discuss?
LDA in brief.
See, parts there.
No, the
So I
topic
can.
is week three LDA. That is
Yeah,
week
these
4.
are. This is so you are still learning week 4 or what?
No, we have not started week 4.
Okay, so
We all are on week 3.
okay. So let's just do one thing because we started like 10-15 minutes late, right? So 10 minutes late, I guess. So what we can do, we can just, because there is no assignment to discuss, we can start with one thing, this perceptron model we have. Okay, just for a theory. So, and you will see it in the, okay, let me, where is my, okay, get my, 1 minute. Note. We'll just quickly start with perceptron model and we'll see what exactly. So perceptron is how we can represent a artificial neuron in computer. Okay. Okay, so perceptron. Let's just remove the whole thing. Okay. Okay. So see, perceptron. I have to have a. Okay. So what it mean is how, let's say, biological neurons are represented in your life science books, right? So it have these dendrons, right? Let me just try to draw a like biological neuron here. It has this body, and then it has this tail, right? And then axon. Whatever is, let's say, yeah, this is the tail, and then it is kind of passing its output or whatever signal it is carrying to the other neurons dendron, right? That is what the biological neuron looks like, and there are this small humps tail which acts as a kind of um, so it acts as a kind of non-linearity to the neuron. Okay, the tail acts as a non-linearity. So what happens? Um, let's say, and there is another dendron here which is passing. So there are another axon here from the previous, let's say, previous neurons, right? Which passes signal to this neuron. So these are known as x1 inputs, x1, x2, x3, and let's say x4. Okay, four dendron, four inputs, x4. And the body, what it does, it associates weights with all the dendrons, weight 3, and here weight 4. What it does, it associates weight with all the dendrons, so it will kind of give more weightage to one particular dendron than the other. Okay, that weight you can represent it as W1 to W4 here. And what it does a summation operation. Okay, So what it does, it takes all the inputs multiplied with the corresponding dendron weights. So the summation would look like x1 omega 1 plus x2 omega 2 plus x3 omega 3 plus x4 omega 4. Okay, and this body also have its own energy that's get added to, and these are all electrical signals. Okay, so if electrical signals are actually added, right, so these all signals will be added, plus the neuron itself has a like initial energy, let's say B, right, B, that will be added at the end, and this will be passed to the, this is known as Z. Okay, that Z will get passed to the axon. Okay, now what axon does, axon applies a nonlinear function, something nonlinear known as sigma. Okay, and sigma for biological neurons, it is actually spikes. So spikes mean so it's, you can represent it as a step function. So step function, how it looks, let's say this is x-axis and this is y-axis, and this is, I'm talking about biological neurons, what research has found so far. Okay, so step function could be like this. This is x equal to 0. Let's say this is z axis and in the activation axis A. So whatever is passed to the other party is activation A. Okay. So from Z to A, what is the relationship? Is this sigma function? How it looks? So for a particular value of Z, let's say Z0, after that value, it will give a 1 and the A varies from 0 to 1. Okay. So either it's a high response or a low response, 0. Okay, so what this sigma function looks like, it's a step. So for all the values lesser than z0, it will give a 0. When it reaches z0, it will spike at beyond and it will give 1. Yeah, so this is 1, this is 0. This is what a like step function looks like, and it gets applied to the z. So now a equal to actually sigma of z, right, and z is this. So this is what a biological neurons mean, like how kind of people have mathematically formulated it. Okay, so how a biological neuron works, this is the mathematical representation of it. Okay, now this is what perceptron model looks like, a mathematical model to mimic the behavior of a biological neuron is known as the perceptron model. And how it is drawn, so this is how I can draw it informally. If I want to draw it formally, I can do it like this. These are inputs x1, x2, x3, x4. They have this there are these weights associated with it, w1, w2, w3, w4. A summation of an is there. There is another, then like another this hand where the value is 1 and the weight is b. Okay, this is the bias component of the initial energy of the neuron, which is represented as b, right? So now how it is represented mathematically? So the input is 1 and the weight of that particular hand is b. Now 1 times b means b, right? So exactly same mathematical model. And then you have a output. Output, you have a some function called sigma, and then this is the output, or you can say it as a for activation. Usually it is represented as y cap. Okay, here you pass z. Then this is the mathematical perceptron model. Got it? How it is related to the biological model? Now sigma can be anything. Okay, sigma is known as the activation function. My writing is so poor here. Activation function. Okay, so it can be anything, but for biological neuron, they have kind of figured out in or found evidence that it is a step function. Okay, for artificial neurons or these perceptrons, we can have multiple functions. For example, we can have sigmoid. right? Sigmoid, or we can have tan H functions, hyperbolic tan, or we can have, let's say, this ReLU function. I will show how these functions look. ReLU function, or we can have a linear function as well. Linear functions also work, okay, for some cases. So how they all look like, and we can also have a step function if there is. So there is this special category of neural networks called spiking neural networks, okay, that uses the step type of activation function. Okay.
Sir, what
So
is B?
what is B? B is the initial neuron energy.
Okay.
Okay.
Thank you.
So or in mathematics it is known as bias. So these are all weights. Mathematically they are known as weights, and this is known as the bias component. And like in biology, that it is not the initial energy of the neuron. Okay, initial energy is B, which is added to this all other energy, incoming energies. Okay. Uh, exactly. So all other incoming signals get added up here, and then the initial cell energy is also added before passing it to the axon. So here it is mathematically represented like this. Now let's see how the other like step function. It is clear that it looks like a step. How sigmoid looks? Sigmoid is something like this. So okay, sigmoid looks like the equation is 1 by 1 plus e to the power minus a minus z. So sigma of z or y cap is like this. So what is the equation? Y cap is equal to sigma of z. Okay. So how it looks? First, see, for z is equal to 0, this becomes 1, right? No, for z equal to 0, e to the power 0. So e to the power 0 means 1, 1 plus 1 half. So for z equal to 0 means my z component to be 0, it is z equal to 0, right? My activation or y cap would be half, 0.5. So how it looks? And for z is equal to infinity, e to the power minus infinity means it is 0, means 1. And e to the power infinity means what? It becomes 0, right? E to the power infinity becomes so for minus infinity it becomes 0. E to the power infinity it becomes, so for if z is equal to infinity it becomes 1. So at this point it becomes 1. And if the z value is minus infinity, so if the z value is minus infinity, it becomes 0, right? 1 by infinity is 0. So how it looks? It looks like a S, elongated S. If I can draw it properly. Now this is how it looks. Okay. Now tan H exactly same thing, but the scale is different. So tan H is like for infinity it becomes 1. For minus infinity it becomes minus 1, and for 0 it becomes 0. So it looks like, sorry I missed the origin. Yeah, it looks like this. Okay. Now how ReLU looks like? You see these are different activations that you will see. Okay. So this is tan H. This is sigmoid. And now how ReLU looks? ReLU looks like, ReLU equation is 0, 0 if x is less than 0, 1, or let's say no, not 1, x if x is greater than 0. Okay. So it looks like, choose the red color. For all the negative components up to 0, it is 0. And whenever you have positive components, it's a 45-degree slope. X is equal to x. This is what ReLU looks like. Okay. And lastly, this linear. Linear is same. Linear is what you expect, right? Linear of z is equal to z. So it will look like a 45-degree line like this. Z is equal to z. Okay, so these are the different activations that we came. So there are other activations too, right? There are this leaky relu, this softmax regress and other things too. But these are the kind of most popular activation function used in like current like neural network deep learning literature. Okay. Now you see, knowing this model, how it helps. So what is basically a neural network is basically you place all those neurons in a formation. So I can write a small neural network here, draw a small neural network, and you can relate to it. That see, these are the inputs. Let's say x1, and these are the input where the inputs start. Let's say three inputs x3, right? And now this is a neural network layer. So this is one neuron n1. This is one neuron. This is one neuron. And neuron means the perceptron model. Okay, so one neuron is represented as a perceptron in the in mathematics. Okay. Now there is a second layer, and let's say there is a one something you are predicting at the end y cap. Okay. Now see, this is the inputs x1, x2, x3. How they are connected in neural network? They are connected like this. This is for, let's say, let's color them. This is for this one. They are all connected this blue neuron. Let's say the green neuron, right? They are also connected with the green neuron, and they are finally connected with the red neuron. So this is what, and what it outputs. Let's say it's N1, right? So A1, A2, A3. And for like have a good nomenclature, it is also used as a like in your superscript, you give the layer number. So it is first layer, so it is first. So N1, 1, N2, 1, N3, 1. So this is N2, 1. This is N3, 1. So the subscript is the layer. So the nomenclature is neuron and then the number of neuron I and the layer number L. Okay, so it's the first layer. So you name it like this. Now this goes where? I don't have other colors, but let's have the same color thing. It's the blue neuron. So it takes A1, it takes A2, and it takes A3. The green one, it takes all of them. And the red one. Like this, right? And what it outputs? It output A1, 2, A2, 2, A3, 2. Okay, and the last model, let's say it's a blue neuron. It takes all of them as input and produces y cap. Y cap, or we can say interchangeably, we can say A1 of layer 3. Okay, you get the entire neural network structure, right? This is the entire neural network structure. Now where this perceptron model or the knowledge of the perceptron model come is how you can represent the whole thing in a mathematical form. So see this, if you just single out on a particular neuron, right? This interaction, everything, how this A1, A2, A3 is related to A2, 2, we can model it as the, if let's say we fixed this sigma 2, sigma 1, if fixed activation sigma 3, if they have fixed activation, we can represent this A22 as what? This is layer 2. So we can represent the weights as W1, 2, layer 2, W2, 2, layer 2, W 2, 3. So 2 neuron, you are connecting to the second neuron, you are connecting from the third neuron from the previous layer, layer 2. You can name this as like this, these three green lines, and you can write the entire equation as sigma 2 times A11 W122 plus A21 W222 plus A31 times W232, right? And there is a initial this is the A2 model, right? So you have a bias also. So bias 2 of the second layer, bias component. So this is what this looks like. And see, it is same as the perceptron model, right? Sigma 2 of sigma means the activation function, then the entire multiplication of the inputs plus the initial bias, right? So this one neuron can be represented as a perceptron model. Right now, if I know the mathematical formulation of one neuron, I can mathematically formalize the whole entire neural network model. Okay, that's what perceptron model is used for, to mathematically represent the entire neural network operation as a mathematical operation. Okay, in matrix operation, to be precisely speaking. Okay, so you can represent the entire interaction from layer 1 to, let's say, activation at layer 1, activation at layer 2, and activation at layer 3. We can, and let's say we have intermediate weights as W1, B1, W2, B2, W3, B3. Okay, so these are kind of representation of the weights. Okay, how we can represent the weights, or how we can represent the entire this layer operation, we will discuss. If I have these parameters known, uh, I can kind of say, based on the perceptron model, I can say y cap would be sigma 3 of sigma 3 of let's go with the input to output. So the x will be multiplied with omega 1, then summed with b1, and then activated with sigma 1. That will act as an input for the second layer. So omega 2 will be multiplied here, plus bias 2 will be added here, and then activated with sigma 2. Lastly, omega 3 will be multiplied, bias 3 will be added, and activated with sigma 3. But let me just take this call, okay? Okay, so yeah, so this is how a entire neural network, let's just talk to here. It's just an entire neural network computation looks like. Okay, so how you can, how this x1, x2, x3 is translated to x1, like x11, x21, x31, that we can represent it by this matrix multiplication, x omega plus b. Okay, so and how this matrix is formulated, it's very easy. See, uh, okay, sorry. Okay, and your output is what? A1, A2, A3, and your interaction is what? How you are interacting? You have biases B1, B2, B3, right? And all the other weights are represented like this. So it's a dense connection basically. Everybody is connected to everybody in the output. So it's a kind of bijective mapping. Okay. Yeah. So how we represent the weights? Weight is like, see, if omega 1 is connected to A1, it is omega 1 1, omega 1 2, omega 1 3. This is, yeah, and this is omega 2 1, omega 2 2, omega 2 3. Lastly, this is omega 3 1, omega 3 2, omega 3 3. Okay. Now this, see what is the operation? A1, I can map it as, and the activation is sigma. Okay, here we are activating with sigma. So what will A1? A1 is omega 1 1 x1 plus omega 1 omega 2 1 x2 plus omega 3 1 x3 plus b1, right? Similarly, we can write A2 and A3. So in matrix, so you can represent the entire interaction with a matrix multiplication. See, the entire omega matrix will be represented this omega 1 1, omega 1 2, omega 1 3, omega 2 1, omega 2 2, omega 2 3, omega 3 1, omega 3 2, omega 3 3, right? And you have a bias component. So bias will be represented as B1, B2, B3. Now how to, so tell me whether x is what? X is basically a vector of x2, x3 and x3. So x1, x2 and x3, right? So what should be the shape? Is it a row vector or a column vector to get this type of a form? So it should be a row vector, right? So that row x1 will multiply with this, x2 will multiply with this, x3 will multiply with this. Same with the second and third, right? So it should be a row vector x1, x2, x3. Now after that, after the entire thing, you will just activate with sigma. So apply sigma with everyone. And what you will get? You will get sigma of, so if I just represent the whole matrix, sigma of x1 omega 1 1 plus x2 omega 2 1 plus x3 omega 3 1 plus b1 for the first entire thing. For the second one, you will get sigma of x1 omega 2 1, x2 omega 2 2, x3 omega 2 3 plus b2. And the last interaction you will get x1 omega 3 1. Oh, sorry. So we have multiplied it wrong. 1 2 1 2 2 2 3 2 3 2, right? So x1 omega 1 3. Oh, this is 1 3, x2 omega 2 3 plus x3 omega 3 3 plus b3. This is the entire thing, right? And you see, if you just write the equation of a1, a2, a3, this is what a1, a2, a3 means. So this is actually a1, a2, a3. So that is how one layer of a neural network works. So that means if you can represent a set of perceptrons with a matrix multiplication and a summation operation. So matrix multiplication and this summation operation with the biases. Okay, biases means they represent initial energy of each neuron in the next layer. Okay, and X means activation of the previous neurons, right? So and in case of here, X is inputs. Now this A1, A2, A3 network. So and then you have a omega and then you have a B, right? So X into omega of that particular layer L and then bias of that particular layer B. Okay. So that is why the entire neural network equation looks like this. So this is what the first layer would output, activation 1. This is what the second layer would output, activation 2. And see, the activation 2 is dependent on activation 1, right? And this is what the last layer would do, activation 3 or Y3 prediction based on this structure of a neural network. this structure. Okay, so this is how the perceptron model works. So the entire mathematical formulation of perceptron here is translated to the network operation like this. Okay, so we'll stop here. We'll see how to implement the perceptron in Python next week or so. Okay, after we discuss that week's assignment questions, obviously, and see. Okay, we'll see how to code it from scratch. Okay. Yeah, if you have any doubts up to this, guys? Hello. Okay, so nobody has any doubt. Fine, that's cool. So let's just stop here. We'll next week we'll first discuss the week 3's assignment questions from the last run as well as the like this run's questions, and then we'll start writing the perceptron and the neural network from scratch. Okay, and then see what are other this LD and PCA is also left, right? We didn't discuss that part, that theory part. So we'll try to cover that as well. Okay. Okay, guys.
Sir, if
Yeah.
WhatsApp group
Yeah, go ahead.
is there any WhatsApp group is there for
Yeah, there is a WhatsApp group. So I can share
can you
yeah, I can share you the WhatsApp joining link, no problem. In the chat. Okay. Okay. After the call, I will send the meeting.
can you
Okay,
sir,
let me just
WhatsApp link?
I can
WhatsApp.
just send. What's the wait.
Sir,
Reading.
hello,
Go ahead.
sir.
Go ahead.
I joined the meeting late, so will I be able to see the video,
Yeah.
recorded
Yeah.
video later?
So you were in the WhatsApp group, right?
Yes, sir. Yes, sir.
Okay, so I will post the week 3's resources, all the video recordings, the slides, everything there.
Okay, sir. Okay.
Saurav's
So
mic
thank you.
is muted. So but you see, you can unmute yourself, right? Saurav? You can unmute, I guess. So I cannot see you here as well. Okay, let me just
Sir, are you
stop.
talking to me?
Yeah, I can. Okay. Wait. Allow mic. Yeah, now you can speak, I guess.
Thank you, sir.
Yeah. Go ahead.
Sir, today one joining the WhatsApp group. Can you share once again in the previous class videos?
Previous year videos means
Correct. This session, evening session
previous
for your
year
lecture.
videos, right? No, previous. Yeah, no, see, previous year I didn't take this course. I took the introduction to I took the introduction to Python programming course last year. So if you want that, I can share you, or you can just subscribe to my YouTube account, right? So you can find all the playlist there. So I have organized them as playlists. But anyway, so I don't
Sure.
know whether this exact sessions recording will be available for the last year. I don't know that, so you have to check it out. I think they will not put the machine learning this question practice sessions there, right? Because then the questions will be kind of they're repeating questions, right? So it is not likely that you will find the videos. Okay, so I'll put this week's yeah, I'll put this week's this video and the presentation in the group. Okay.
Okay, sir. Thank you.
Okay, thank you. I'm closing the call if nobody has. Yeah, go ahead.
Sir, I am taking the course of Introduction to Machine Learning, Tamil, sir. Can I get any videos link videos links in the WhatsApp groups.
Videos. You are in the WhatsApp group?
Sir, I'm in the
You are
WhatsApp
already.
group, but I need
Okay.
to, yeah, I need to get this
So
is the problem solving session in the WhatsApp group for Introduction to Machine Learning Tamil.
okay. So that there is no kind of live sessions, or there are like TAs who are taking live sessions for the introduction to machine learning with Tamil codes.
Yes, sir. And yes, sir. There is no WhatsApp
No
link
TA, right?
classes, no.
Okay, so I don't think there will be. So if there are no TAs assigned to that course, I don't think there will be any live sessions running. Okay. So
Yes, sir.
yeah, so best to stick with these live sessions. Um, yeah, I guess the recordings are only available in Tamil, but there are no specific dedicated TAs to take live sessions on Tamil, right?
Yes, sir. Yes, sir.
So I would say ki just stick to this because the questions will be similar. Stick to these live sessions if you can. Okay. Okay.
Okay. Okay.
Okay.
Okay.
Thank you,
Thank
guys. So
you.
so just
Sir,
like feel free to go ahead.
YouTube, YouTube videos for your classes, the
Yeah,
WhatsApp group.
it is. You can check the group details. Group details. There is my YouTube channel's link. You can find it there.
Yeah. Okay. Thank you, sir.
Okay. Thank you. Thank you, everyone. So we'll see in the next class about the next week's. So this week 3's assignment questions, and then we'll try to implement Perceptron and this neural network from scratch. And we'll see specifically how these models are trained. Okay. So that's a very, so we can the forward first. So this entire X to Y cap, this is known as the forward first. Okay. So there is this mechanism called back propagation, which is used to train those weights. So tune those weights such that my predictions become closer to the target. So that algorithm is still remaining. We'll discuss that algorithm, try to implement the whole algorithm, the forward first from scratch. Maybe it is not covered in 1 week, maybe it will take 2 weeks, but let's see. Okay, we'll see from the next week. After we obviously discuss the week's assignment questions. Okay, thank you, everyone. I'm
Thank you,
stop
sir.
recording. Stop
Thank you,
recording.
sir.
Thank you, sir. Thank you.
Thank you,